we're doing position, velocity, acceleration. Tom Petty's a skydiver. I thought he was a singer. When he free falls, his downward velocity, v of t, is a function of t, seconds, from the time of the jump, and is given by velocity equals that function in feet per second. Plot v of t and a of t on your calculator for the first 30 seconds of his fall. So that means we are supposed to graph these on the calculator. So something I'm supposed to know, and I hope you've already got these in your notes, that S of t is position. Sometimes when we're talking about going left and right, they use x of t. S prime of t is equal to v of t, which is the velocity. And then the second derivative of s, which is the first derivative of v, is equal to a of t, which is acceleration. So we're supposed to plot these on our calculator. So I'm going to put b of t in for 1, and I'm going to hopefully, I don't know if this thing's working. That is not showing anything. Let's see if I turn my camera on here if it'll work. It's not showing anything. Anybody know anything about these? Broadcast RTM address is not setting. What does that mean? Okay, I'm going to turn this off and turn it back on and see if that works. Hopefully this will get it going. There's still nothing there. Anybody in here know about these things? Okay, I don't know why this camera's not working, people at home, so I guess I'm not going to be able to show you, so I'm going to explain to you what I'm typing in as I do this. So I'm taking my calculator, and I'm going to Y1, and I'm going to type in exactly what that says. So I got 25 left parenthesis of 251 left parenthesis. Thank you for straightening me out. And then 1 minus 0.88 raised to the, now we're going to put x in there because we're going to use x instead of t. And just remember t is time in seconds. So I've got that typed into my y sub 1. Now I want to also graph a of t. Well, we're supposed to know a of t is the derivative of that v of t. So I'm going to arrow down on my calculator to y sub 2. I hope everybody's doing this with me. So at y sub 2, I'm going to hit math 8. That gives me the derivative in my screen for y2, and I'm going to type an x in first under the d, and it's got d blank. I'm going to take x. Now I put that first equation in there in y1, so I'm going to do put y1 in there because I want the derivative of that velocity. So I'm going to hit vars. I'm going to arrow to the right to y bars. I'm going to hit 1 for a function. I'm going to hit 1 again to get y1 in there. And now I want to graph it when x equals, and we don't want a numerical value. We want to leave x. So we're going to put x in there, which is to the right of alpha. So at the bottom it says x equals x. So we're going to graph these two. So I'm going to graph these, and I got a feeling I'm going to have to change my window. I know I am. So I'm going to change my window right now. So anyway, we're talking about Tom Petty being a skydiver. And if you look at that 251, that's telling me that I'm going to have probably a fairly good sized number for Y value at the top. So I'm going to change, and I want the first 30 seconds. So I'm going to change my X. X is my seconds. I'm going to change that from, again, I'm hitting window, and I'm going to hit 0 for X min, and I'm going to hit 30 for Y X max, because it says from 0 to 30. Okay, and then I'm going to come down and change my Y min to 0, because we're talking about above the ground, or actually velocity is 0, and let's see, we're going to go up to, I'm going to go up to 300 for my Y max and try that. And I'm going to graph that and see if that helps. Oh, that makes it much nicer. So I've got that one. Now, when you do the derivative graphing, you're going to notice it takes forever for the derivative to graph, because your calculator's got to do the derivative of each little point, and it takes forever. So when I look at my graph right now, and I use the window I just told you, my velocity function I'm going to show you down here. So I had this thing going up to 300, and I was starting down here at 0, and I went over here to 30 seconds. This is t. This is v of t. And so my first function came in and kind of did something like this. And then when I did my derivative function kind of went like this. Something like that. So that's what you should be seeing on your screen, I hope. Okay, so
yes.
the question asks, what is Tom's acceleration when he first jumps? So that's
So I tell you the answer.
Now acceleration is my green line. So what I'm going to do is I'm going to hit second calc, and I'm going to type the number 1 in there, and I'm going to put 0 in, and I'm going to hit enter. Now, if you look on your screen, it's got the blue equation at the top. So that means that's for the blue equation. So I'm going to arrow up, which switches to the red equation in my case, or the green one on my screen. So when I type that in there, that is 32.086176. I'm going to write that down. So, okay, I'm going to do this again. So I've got my graph on there, and I am trying to find acceleration. Oh, it says at 10. I didn't want 0. I shouldn't have typed 0. Oh, yeah, when he first jumped. So I want A of 0. I want A of 10. I want A of 20. And I want A of 30. Now on this picture, that's the green one. On my graph, on my calculator, it's red. So I'm trying to find these on my calculator. So the first place I'm going to look for is this one right here. I want to know what is that acceleration value right there. So I'm going to hit second trace, which is calculate. And then I'm going to hit 1. So I'm going to plug the value of 0 in there and hit enter. Now, once again, on my calculator, it is showing me the blue graph. Because up at the top of the screen, it says Y1. Yours should say the same. We don't want the red graph. We want the green graph. So we're going to arrow up, and then that changes at the top of the screen. It says Y2 now. That's the one we want. So when I look at that, that is 32.086176, and I'm going to round to 3 decimal places. So this is 32.08 And it's 6.1, so I'm going to leave it 6. Now, this does not say to do units, but I'm going to do units to help you out. So velocity, if you look up here, velocity is in feet per second. And this is the slope of that. So feet per second is your y value, and your x or t value is seconds again. So this is actually feet per second, or you could say feet per second squared, because this is the y value and this is the x value, or the t value in this case. Now I'm going to do the same thing and find the value at 10. So I'm going to hit second trace again, which is calculate. I'm going to hit number 1, and I'm going to type in 10 and hit enter. Now again, it's on the blue one, so I got to arrow up and it goes to the red one, and that value is 8.936. So I'm going to write that down. 8.936. Now it is again this same thing, even though it's not asking that. Now I'm going to do the same thing and hit second trace again and hit 1. I'm going to type in 20, and it's going to be the wrong one, the wrong function, the blue one. I'm going to arrow up, and now it's 2.489 when it rounds. 2.489. And then the last one, I'm going to hit second calc again and hit 1 and type in 30. And got an arrow to the right graph, and that's 0.693. So it asks, what's the limit of velocity as t approaches infinity? What is the limit of velocity, and what is the technical term for that? Ooh, I'm not even sure what the technical term is for it.
It's terminal velocity.
Oh, that is it. You're right. Terminal velocity. So this is terminal velocity. Now, I'm going to show you first of all, or explain to you first of all what to do to find it. So what you might want to do is you could trace your blue line, but you want to trace it way over on the right. Or we could put a value in there, and we could hit second trace again and do value 1 and type in a big number like, I'm going to hit 30 because that's on my graph, and hit 30, and then it's up there. So it says 245.57. Then if I keep arrowing to the right, oh, it won't let me arrow to the right. I'm going to go to my table. I'm going to hit second window and go to table set, and I'm going to tell it to start the table at 30, and I'm going to go by 1. So the change in table, I'm going to put 1, I guess, and then I'm going to hit enter, and then I'm going to hit second table. So it tells me at 30 it's at 245. Now as you look down that screen, as you're going down to 40, it's 249.50, and you keep going down, down, down. It keeps getting bigger and bigger. Well, what we're going to find out is the limit as x approaches infinity for the velocity is going to be this number right here in front, that 251. So it's going to reach a maximum velocity of 251 feet per second. Okay? But you can find it on your calculator, and the closer you get to the bigger the t values or x values you plug in, the closer it's going to get to 251. So in other words, if you're looking at the screen up here, as I'm coming this way on this graph, this is coming really close to where, I'm going to erase that and say this is 251. If I took 251, that's my horizontal asymptote on this thing. And the further this graph goes out here, the closer and closer and closer it's going to get to 251. Okay? All right, so that's problem 14. Does anybody else have anything you want me to do on this? Anybody else got any 4-2 problems? Because if not, we're just going to stop and let you work on it for a while. All right, so I'm going to go ahead and call the recording off. And you guys at home, work on your 4-2. Tomorrow, we're going to do a Zoom again during your regular time. So if you have more questions tomorrow that we're not covering, you can get them answered tomorrow. Please, please get 4-3 watched before the weekend's over. And I will see everybody on tomorrow's Zoom.